Okay, next I will talk about the second chunk of questions. Question 11, we're having integral of cube the root of u squared du. Then this is going to be, if you change this into a format of u to the power 3 over 2 du, then it'll be easier to use the power rule. You will get u to the power of 5 over 2 because 3 over 2 plus 1 is going to be 5 over 2. Now the coefficient is going to be 2 over 5 because when you move this to 5 over 2, it's almost like a 1 divided by that fraction. It's the same thing as multiply. It's a reciprocal, and plus c. Question number 12, you'll be getting integral u to the third and the fifth root du. Then you want to change, first you want to convert this fifth root into some types of power way. Therefore, it's u to the power of 3 over 5. It's always the inside exponent goes to the top, outside exponent goes to the bottom. Therefore, it's a 3 over 5 and du. And you will get, if you notice, I always write this, leave a little space in there so that I will need to have a coefficient to balance it. And when you increase by 1, that'll be 3 over 5, 3 over 5 plus 5 over 5, which is 1. And this is the coefficient you want to balance it. And let me write, and this which is 8 over 5. And this is the 5 over 8 if you balance it, the plus c. I need to write it in a nice way. This is more of your calculation on your head. In your head, this is a 5 over 8, u to the power of 8 over 5 plus c. And number 13, we're having integral of 6x squared plus 4x dx. And this is the part we talk about when you have two functions multiply each other. Sorry, when you have two functions add to each other, then you can just integrate them separately. And therefore, this becomes a 6 x to the power of 3, 1 over 3 to balance it. For the second part, it's a 4 and x squared, and you want to multiply, let me write this way, x squared, and you want to have 1 over 2 balance it. And you just need to plus one of the constant. Both of them will generate a constant so that it can be when you take an antiderivative, but together it's still constant. So we just need to plug in 1c. Then if you rewrite this or simplify this, you'll get a 2x to the power of 3 plus 2x to the power of 2 plus c. And the point for this question is to recognize you can just integrate them separately. Number 14, you get an integral of 8x to the third plus 1 dx. And for this case, you will get 8. I will leave a little space, x to the power of 4 and a 1 over 4 plus the derivative, the antiderivative of 1 is just x because the derivative of x is 1 and plus c. Simplify this, it will be 2x to the fourth plus x plus c. Number 15, you get what is the integral? X squared plus x plus 1 dx. Then this will becomes x to the third, 1 over 3 plus x squared, 1 over 2 plus x plus c. It's pretty straightforward. Then number 16, you will get integral 3u squared plus 4u to the third. This is a u du. Then what you get is, this is a 3, live in there, u to the third, 1 over 3, so that this two balance to get u squared, plus 4, u to the fourth, 1 over 4, so that this 4 balance, this 1, 4 cancel each other, will give you u to the third plus c. And when you simplify this, you will get u to the third plus u to the fourth plus c. Then we'll get to number 17. For 17, Start from 17. The question sometimes is getting a little more not that traditional, such that just the exponential. Number 17, you're getting square root of 2 times u to the 0.1 minus 0.1 u to the 1.1 and a du. And for this case, you want to continue with, you want to keep that a constant, then increase by 1, 0.1 increase by 1 becomes 1.1, divided by 1.1, minus, keep that 0.1, increase 1, make it a 2.1, 1 over 2.1, and plus c. It's an indefinite integral. And therefore, you can just leave like that or make it look more simplified. Minus 0.1 divided by 2.1, u to the 2.1 plus c. Then number 18. Number 18 is integral of 3 over t squared minus 6t to the power of 2 dt. Now you have a negative exponent because I can rewrite my question such that this is 2t to the power of negative 2 minus 6t squared dt. Now because it's a indefinite integral, therefore it's 2t to the power of negative 1 because you want to increase by 1. Then this is going to be 1 over negative 1 so that it balances, minus 6t to the power of 3, 1 over 3 to balance that 3 plus c. And you will get 2 divided by negative 1 is just negative 2. T to the negative 1 minus 6 divided by 3 will be 2 t to the third plus c. You could do one more step to just making sure you don't have a negative exponent. This will be 2 over just a t to the power of 1 is still t minus 2 to the t to the third plus c. And number 19, you get integral t squared minus 1 dt, and that will gives you integral of t squared will be t to the third divided by 3 minus t, making sure plus c in there. Because this divided by 3 is really just 1/3 to put to the front, so you can balance that t to the third. Now number 20, integral t to negative 2 plus 3 dt. And you want to integrate the t to negative 2, therefore t becomes t to negative 1. It's always increasing, making sure when you have a negative exponent, it's increasing. Then it's 1 over negative 1 plus 3t and plus c. To simplify this, this is more like a negative because 1 over negative 1 is still negative 1. 1 multiply anything, just a negative value. 1 over t plus 3t plus c. Okay, this is the next 20 questions. In the next section, I will cover from 21 to 30.